All right, today we're taking a sidestep from the things that are in your notes packet and your textbook. We're going to talk about rational expressions and more operations on radicals, because before we dive into the next stuff, we should talk about this. So a rational expression is a ratio of two polynomials. Rational means fractional. It's just a polynomial over another polynomial. So to simplify, the first step for simplifying, I'll put those steps right up here. Step 1, factor everything. So I'm going to factor my numerator and my denominator. Factor my numerator, I get x plus 4 times x minus 4. My denominator is x minus 4 times x plus 3. Factored everything. Perfect. Step 2. Cancel common factors. Remember, 1 in the numerator and the denominator. So I have an x minus 4 in both. Remember, you can only do this once it's factored out. You cannot just start crossing stuff out that it has in common. So like over here, I can't just cross out my x squareds. Nope, only once it's factored. So that leaves me an x plus 4 over x plus 3. Can't simplify anything else about it. The only other piece to this is restrictions. And the restrictions are when the denominator equals 0 at any point in the problem. So you have to be careful, because looking at this, yes, we see that x can't equal negative 3. But in the step above it, I also had an x minus 4 in the denominator. So x also cannot equal 4. Even though that's not an issue with our simplified version, x still can't be 4 because at some point in the problem, that was in the denominator. So for our next one, we start by factoring everything. The numerator, I can take out the GCF of x, leave x minus 8. In the denominator, I have x minus 8 times x plus 1. I cancel my common factors, leaving me x over x plus 1. I can't do anything else to that. That is simplified. Then we state our restrictions. Well, obviously, x cannot equal negative 1. But looking back a step, x also cannot equal 8. Always remember, look at every step. All right, multiplying and dividing. Multiplying and dividing, we're going to add a few steps. For multiplying and dividing, step 1 is still factor everything. Every numerator, every denominator, just factor it all out. So my first one, it factors into, let's see, 2x and x. 21 would be 7 and 3, so positive 7 minus 3. Over our denominator, let's see, I get an x out of that. X squared plus 2x plus 4. And thinking about it, x squared plus 2x plus 4 is not going to factor again, so that one's going to be there. X cubed minus 8, that's our difference of cubes. Remember, a cubed minus b cubed becomes a minus b times a squared plus ab plus b squared. Sorry about my curvy right in there. So a is x, b is 2, because 2 is cubed makes 8. So I have x minus 2 times x squared plus 2x plus 4. And my denominator, I have x and x. That'll be a plus 7 and a minus 2. All right, step 1, factor everything out. Step 2, cancel. But any numerator / denominator combo, you can cancel diagonally. Oops, sorry, you can't see that part. So I have a 2x minus 3 here. No other 2x minus 3s, it's stuck. X plus 7, well, there's nothing in the same fraction, but over here I have an x plus 7 in the denominator, so they can still cancel. X minus 2 is in its own fraction, so those cancel. X squared plus 2x plus 4 is over here. They can cancel diagonally, leaving me just 2x minus 3 over x as my simplified version. And the last step, as usual, is restrictions. If at any point in time the denominator was 0. So x can't be 0. X squared plus 2x plus 4 does not give any real solutions, so we don't worry about that. X plus 7 means that x cannot equal negative 7, and x minus 2 means that x cannot equal positive 2. That's for multiplying. If we are dividing, we have one extra step. And you can either do it first or second, it doesn't matter. But we need to make it multiplying by the reciprocal of the second fraction. Keep, change, flip is a common term I've heard. Keep the first one the same. Change to multiplication, flip the second one over. All right, then we just treat it as multiplication. We're going to factor everything. And you can factor before you flip, that's fine as well, but you cannot simplify it until after you flip. So I factor everything. X cubed plus 1 is x plus 1 times x squared minus 1x plus 1. X squared minus x minus 2 is x minus 2 times x plus 1. X squared minus 4x plus 4 is x minus 2 times x minus 2. And x squared minus x plus 1, not going to factor, so I leave it. There we go. Now, again, we cancel. So I have x plus 1 and x plus 1, x minus 2 and x minus 2, x squared minus x plus 1. I'm just left with x minus 2. Much simpler, right? So now we look for restrictions. Well, x minus 2 is in the denominator, so x can't be 2. X plus 1 is in the denominator, so x cannot equal negative 1. This denominator will never be 0. But also remember that originally our denominator was here. And it moved to a numerator here, which is this numerator now. So x can't be positive 2 or positive 2. We already said those, so not a big concern. Add or subtract. Now is when things get super fun. Anytime you add or subtract, you need a common denominator. And in further problems, we'll get a common denominator in a slightly more complex way, but for this one, I have 4a and 10a. Well, 4 and 10 can both become 20. I multiply the 4 by 5 in the numerator and denominator. The 10 gets multiplied by 2. A and a squared, we want to make them into a squared, so we need to multiply an a into the numerator and denominator of that first fraction. 5a times 7 is 35a over 20a squared, plus 11 times 2 is 22 over 20a squared. Once you have your common denominator, we can combine. Remember, when you add fractions together, you do not change their denominator, so we just have 35a plus 22 over 20a squared. The final step is to simplify if you can. Looking at this, there's no GCF, nothing I can simplify. That is our final answer. Can't go any further. And never forget our restrictions. Well, a cannot equal 0 because that's in the denominator. That's the only thing a can't equal. There we go. All right, polynomials make it a tiny bit more complex. Step 1. We still need a common denominator. But to do that, we are going to factor only the denominators. You can factor the numerators, but it makes your life harder. So leave my numerators, factor the denominator. That one becomes x plus 3 times x plus 1 minus, leave the numerator, factor the denominator. I have x plus 3 times x minus 1. All right, don't look for things to cancel. Not going to be helpful here. Step 2 is to get the common denominator. And to do that, we multiply by factors that each term doesn't have. So this first one has an x plus 3 and an x plus 1. The second one has an x plus 3, so they have that in common. The second fraction has an x minus 1. The first fraction doesn't, so we multiply in an x minus 1 to the numerator and denominator. Then I notice the first fraction has an x plus 1, the second one doesn't. So I multiply in an x plus 1 to my numerator and denominator. The next step, step 3 I'll call it, multiply out those numerators. We're not multiplying them together, we're multiplying to make that common denominator. So this first one becomes 3x squared plus 5x minus 3x minus 5. Do not multiply out your denominator. That'll make your life harder. Minus, this one is x squared plus 1x minus 5x plus, minus 5. All right, now I'm going to simplify those just because simplifying things makes them better usually. So I have 3x squared plus 2x minus 5. Sometimes I skip writing out the denominator every time. X squared minus 4x minus 5. And in order to combine these fractions, since I'm subtracting, I would also take a little side step, change it to adding, and distribute that minus. Just because now I don't have to write it out separately, I can actually add my fractions. So that's going to be my step 4. Add or subtract. So 3x squared plus negative x squared is 2x squared. 2x plus 4x is 6x. Negative 5 plus positive 5 is 0 over that whole denominator. All right, we are in the home stretch now. Now is when we'll factor the numerator. I can take a 2x out of both of those, leaving me an x plus 3. And our final, well, almost final step, simplify by canceling like terms. I see that this has an x plus 3 in the numerator and denominator, leaving me 2x over x minus 1 times x plus 1. And the actual last step here is our restrictions. So in our very last step, x can't equal 1 or negative 1. If I look back one step, x can't equal negative 3. And then just look through all my steps before to make sure there's nothing else. That's it. There's our answer. Now we're getting wonky. We have a complex fraction. Fractions within fractions within fractions within fractions. For a complex fraction, simplify the numerator first. and the denominator in their own. So my numerator, 1 over 8x plus 2x over 8x. Well, they already have the same denominator. So I make it 1 plus 2x over 8x. Awesome. Now let's look at my denominator. 1 over 2 plus 1 over 4x. Well, they need a common denominator. 4x can work. Multiply that first one by 2x. So I have 2x plus 1 all over 4x. All right, there's step 1. Then, I always like to rewrite them side by side. So I have 1 plus 2x over 8x. A big fraction bar is really just divided by 2x plus 1 over 4x. And now we keep, change, flip. Keep the first one the same, 1 plus 2x over 8x. Change to multiplication, flip the second one over. Now we're just treating it just like multiplying. Look for common factors. Oh look, 1 plus 2x and 2x plus 1 are the same thing. Now I'm left with 4x over 8x. Well, those x's cancel out, leaving me just 4 over 8. 4 over 8 is just 1/2. And finally, our restrictions. Well, at this point, there's no restriction. But in this step, x couldn't be 0. If I look back another step, x can equal -1/2. Look back further, x still can't equal 0. And that's everything, all of our issues. So let's try another one. Deal with the numerator and denominator separately. So, numerators first. Let's get a common denominator. I have a 3 and a 3x. That means this first one has to get multiplied by x. That gives me x squared. Remember to distribute your minus. So minus 2x minus 3 over 3x. In the denominator, I have a 3 and a 3x. This one needs to get multiplied by x. I have x plus 1 over 3x. Now again, I always like to rewrite it. May seem like an extra step. X squared minus 2x minus 3 over 3x divided by x plus 1 over 3x. I like to do that because then I visualize, oh, I need to flip this over and multiply. So that's what I'll do. X squared minus 2x minus 3 over 3x. Now it is times 3x over x plus 1. Now I treat it just like a multiplication problem. I factor everything. That numerator factors into x minus 3 times x plus 1. The 3x is stuck. Times 3x over x plus 1. Cancel anything I can. Vertically I can't cancel, but diagonally I can. Leaving me just x minus 3 for my answer. Now we look at our restrictions. In this most recent step, x could not equal -1. In this step here, x cannot equal 0. Looking back, no other changes. X just can't be -1 or 0. Now we're going to talk about solutions. An extraneous solution is a solution of the new equation that's not a solution of the original equation. So in our example here, to undo a square root, we square, right? We get 9x plus 10 equals x squared. Subtract the 9x and the 10 over, so that it's equal to 0. Factor. Our solutions are 10 and -1. When I plug these in, 9 times 10 is 90. 90 plus 10 is 100. Square root of 100 is 10. That works. 9 times -1 is -9. -9 plus 10 is 1. The square root of 1 is not -1. -1 is an extraneous solution. The way we solve it gave me an answer that doesn't actually work. So we really have to go back and check our work on these. So let's solve our problem. On these problems, I recommend just getting a common denominator on everything. So my 2 is originally over 1. I see that I can make all of those denominators a 3y. Multiply the first one by 3, second one's good, third one should be multiplied by 3y. So I now have 45 over 3y equals 21 over 3y plus 6y over 3y. The reason I like to do it this way is because now I take everything and I multiply by my denominator over 1, because that cancels all the denominators. I'm now solving 45 equals 21 plus 6y. I solve it just normal, subtract 21. I get 24 equals 6y. Divide by 6. I get y equals 4. Before saying that's your answer, we always need to check it. Is 15 over 4 equal to 21 over 12 plus 2? I don't want to check that in my head, so I grab my calculator. 15 over 4, is that equal to 21 over 3 times 4 is 12 plus 2? Look at that, they are equal, we're good. This is my actual answer. Usually the things that'll be an issue would be things that make you divide by 0 or a square root of a negative. All right, now for this one, we start off just like we do, adding and subtracting rational expressions. Get a common denominator. To do that, we factor the denominators. And the only denominator we can factor here is this last one. It becomes x minus 5 times x plus 1. Now I like to get a common denominator on everything. Well, I see that they all use the same 2 factors. This one is missing the x minus 5. The first one is missing the x plus 1. And then we distribute that in. So I have 3x squared plus 3x over x plus 1 times x minus 5 equals 2x minus 10 over x plus 1. X minus 5 plus 2x squared plus 40 over x plus 1 times x minus 5. Now we get to do that same step we just did a second ago. We multiply everything by the denominator. Now you can skip writing this step out because once everything has the same denominator, you can essentially just ignore it. That's essentially what we're doing. That denominator is important in a moment, but not for another moment. To solve, we want to get everything on one side. There we go. So I get 1x squared plus 1x minus 30. I factor x plus 6, x minus 5. My solutions are x equals negative 6 and x equals positive 5. Now is the checking step. I go back up. Essentially, you only need to check if any of those would make your denominator 0 at any point in time. Well, just looking at this step, negative 1 and positive 5 are the values that x could not equal, right? Which means when I got x equals 5, that is extraneous. Because of our methods for solving, that became a solution, but it's not actually a solution. To check negative 6, I recommend calculator. Go back to the very original. If it's not going to give you an a denominator of 0, go back up here. All right, negative 6 is what I'm checking. So that's negative 18 over negative 11, okay? So I have 2 over negative 5 plus 2 times 36 plus 40 over 36 plus 24 minus 5. I did a little bit of the simplifying in my head. I got 1.636363. Hey, look at that. They're equal. We have one solution to this problem. It is -6. And now for some radical equations. Radical equations are pretty straightforward, right? To undo a square root, we square. But when we square t minus 5, remember that we are actually FOILing. T minus 5 times t minus 5. Well, t plus 7 squared, or the square root of t plus 7 squared, is just t plus 7. T minus 5 times t minus 5, t squared minus 10t plus 25. Get it equal to 0, so subtract a t and subtract the 7. 0 equals t squared minus 11t plus 18. And then factor 0 equals t minus 9 times t minus 2. So my solutions are 9 and 2. But check. Checking is very, 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 very important on these. If I check 9, 9 plus 7 is 16. The square root of 16 is 4. 9 minus 4 is 4. 4 equals 4. Good. 2. 2 plus 7 is 9. Square root of 9 is 3. Awesome. 2 minus 5 is -3. 3 does not equal -3. That's an extraneous solution. So in square roots, it'll be either making you take a square root of a negative or giving you a square root equals a negative, both of which not allowed. All right, if you have 2 square roots, here's where we get really crazy. Get one of them alone. So I'm going to add the square root of y minus 2 over to the other side, giving me the square root of 4y plus 1 equals 3 plus the square root of y minus 2. Now we square both sides. The square root of 4y plus 1 squared is just 4y plus 1. When I square 3 plus the square root of y minus 2, I need to FOIL, and it gets a little wonky. So I'm going to write it out. So when we FOIL this, 4y plus 1 hangs out. 3 times 3 is 9. 3 times the square root of y plus 2 is 3 square root y minus 2. Sorry, minus. Square root of y minus 2 times 3 is positive 3 square root y minus 2. Square root of y plus 2, sorry, minus, times the square root of y minus 2 is y minus 2. Combine all of our like terms. 4y plus 1 equals 7 plus y plus 6 square root y minus 2. The 7 and the 6 cannot combine because the 6 has a square root next to it. Now, get our square root alone again. Subtract 7, subtract y. 3y minus 6 equals 6 square root y minus 2. Now there's 2 things you could do here. You could get the square root completely alone and divide that 6 over, but then we're dealing with a 1/2 in front of the y. I personally would rather square it as it is. So I square both sides. When I square 3y minus 6, remember it's 3y minus 6 times 3y minus 6, which is 9y squared minus 18y minus 18y plus 36. When I square this side, since they're multiplied together, remember you can distribute a square into multiplication. So 6 squared is 36. Square root of y plus 2, or sorry, square root of y minus 2 squared is just y minus 2. And now we solve. I have 9y squared minus 36y plus 36 equals 36y minus 72. Get it equal to 0. Subtract that 36y. Add the 72. I have 9y squared minus 72y plus 108 equals 0. Take out my GCF, which is 9. I have y squared minus 8y plus 12. And finally, y minus 6, y minus 2. So my values are y equals 6 and y equals 2. Check them now. Go way back to the beginning. Whoop. 4 times 6 is 24 plus 1, 25. Square root of 25 is 5. Minus 6 minus 2 is 4. Square root of 4 is 2. 5 minus 2 is 3. Y equals 6 works. Try 2 now. 4 times 2 is 8. 8 plus 1 is 9. Square root of 9 is 3. Awesome. 2 minus 2 is 0. Square root of 0 is 0. 3 minus 0 is 3. In this one, both solutions worked. That can happen. So now, your assignment will be a rational and radical equations worksheet.